Earth is the only place in the universe where we know life exists. But what makes this small blue planet so special? To find the answer, we have to go back, far back, through deep time. Imagine watching the first humans take their first steps on this land. Continents crashing together and tearing apart, walking beside giant, deadly dinosaurs, diving into ancient oceans filled with strange, alien creatures, feeling the freezing grip of global ice ages, and witnessing cosmic impacts that nearly erased everything. By traveling through these areas, piece by piece, we uncover the story of our planet, how Earth survived, evolved, and became the only home we have ever known. And in this process, we learn why we are here at all. Our journey begins almost 5 billion years ago. There is no Earth yet, only the Sun, a young fiery star wrapped in a swirling cloud of dust. At first glance, it seems impossible that anything meaningful could come from these debris. But over time, gravity starts doing what gravity does best. It pulls dust into tiny grains, then into rocks, and eventually into massive chunks of matter. It's almost unbelievable. A planet something as complex as Earth begins from nothing more than drifting dust and scattered stones. For millions of years, these pieces crash and merge, growing bigger and bigger until one of them becomes Earth. But this early Earth looks nothing like home. In fact, it doesn't even look like a place where life could ever exist. 4.5 billion years ago, Earth is a nightmare world. Up close, the temperature soars above 2000 degrees Fahrenheit. The air isn't air at all, just toxic mix of carbon dioxide, nitrogen, and thick water vapor. Get anywhere near it and you would be burned, choked, and gone within seconds. This young planet is nothing but fire. A glowing sphere of liquid rock, a world made of lava, ocean of it, stretching in every direction. Suddenly, a young planet named Theia is on a collision course with Earth. About the size of Mars, it's racing through space at nearly 10 miles per second, around 20 times faster than a speeding bullet. As it approaches, its gravity begins to stretch and twist Earth's molten surface. Then the impact hits. The explosion sends a shockwave racing around the planet. For a moment, both worlds practically turn to liquid. Trillions of tons of molten debris are blasted into space, forming a fiery cloud around the shattered Earth. But gravity isn't done yet. Over the next 1,000 years, all that rubble starts circling Earth, forming a glowing ring of red, hot dust and rock. From this ring, a huge sphere begins to take shape, over 2,000 miles wide. This is the birth of our moon. But it's not the moon that we see today. It's much closer, only about 14,000 miles away. Instead of 250,000 miles it operates at now, hanging massive in the sky. Meanwhile, Earth begins to cool. The sun rises and sets incredibly fast. A full day is only about 6 hours long. The planet is spinning at an insane speed. Time flies, but the transformation of Earth does not. To truly see how our world evolves, we need to fast forward through millions of years of dramatic change. About 3.9 billion years ago, Earth comes under attack. A relentless hail of meteors, leftover debris from the birth of the solar system, crashes into the planet. Inside these space rocks are tiny crystals, each no bigger than a grain of salt. and inside those crystals, minuscule droplets of water. These destructive missiles may actually be delivering the most important ingredient for life. Each meteor carries only a trace amount of water, barely noticeable. But over more than 20 million years of non-stop bombardment, those tiny droplets added up. Pools of water begin to form. Oceans begin their first outlines. Earth's core is still molten, but its surface finally cools enough to form a solid crust. The air temperature drops about 170 degrees Fahrenheit. Still scorching, but no longer the fiery furnace it once was. And here is the wild part. The water we drink today, every sip, every wave in every ocean, is billions of years old. Some of it may have traveled millions of miles to reach Earth, sealed inside ancient meteors. The planet is starting to look familiar, but it's far from peaceful. 700 million years after Earth's birth, water finally covers most of the surface. Tiny islands begin to appear, seemingly out of nowhere. Their organ lies deep below, molten rock pushing through the crust, rising through the ocean, and cooling into volcanic islands. These islands will one day merge to form the world's first continent. Now, Earth has both oceans and land. It's starting to look like a real planet, a future home. But the atmosphere is still toxic, and the heat is still extreme. For now, life here is impossible. Since Earth first formed, meteors have been smashing into its surface. But around 3.8 billion years ago, something changes. The bombardment becomes even more violent. Something out there has disturbed the orbits of these space rocks, sending them straight toward our planet. And they are carrying more than just water this time. As these meteorites dissolve in the young oceans, they release minerals, carbon, and even primitive proteins made of amino acids. These ingredients travel from outer space all the way to the bottom of the Earth's oceans. Thousands of feet below the surface, the world is pitch black and freezing cold. But something extraordinary is taking shape. Hydrothermal vents, towering underwater chimneys, are blasting hot, mineral-rich water into the ocean. Cold seawater seeps into cracks in Earth's crust, heats up deep below, absorbs chemicals, and then erupts back into the ocean, building these strange towers. Here, mixed with the minerals delivered by meteorites, the water becomes a kind of chemical soup. And somewhere in this soup, somehow, life begins. It's impossible to know the exact moment, but these chemicals combine to form the first microscopic organisms. Single-celled bacteria, simple, tiny, and incredibly tough. Life has officially arrived on Earth. For hundreds of millions of years, nothing changes. No planet, no animals, just endless oceans filled with single-celled bacteria. To find more complex life, we jump ahead to 3.5 billion years ago. Like rocks rising from the seabed, are actually colonies of living bacteria. They are called stromatolites. The bacteria can do something revolutionary. They turn sunlight into food, which this process is called photosynthesis. They use light, water, and carbon dioxide to make sugar, simple fuel for life. And as a byproduct, they release oxygen. Slowly, as stromatolites fill the oceans with oxygen, the oxygen reacts with iron in the water, turning into rust, which sinks and forms thick layer of iron-rich rock. The same iron that will one day become our bridges, ships, and skyscrapers. Above the water, oxygen begins transforming the atmosphere. These simple bacterial colonies are creating the most important element for life. Without them, almost nothing we know today would exist. For the next 2 billion years, oxygen levels rise, and Earth keeps changing. The planet's rotation slows down. Days stretch from just a few hours to about 16. Around 1.5 billion years ago, Earth is a blue planet dotted with volcanic islands. Deep beneath the oceans, the crust begins to crack into massive lumps, tectonic plates, and beneath those plates, Earth's burning hot mantle churns and shifts. Heat from the core creates movements in the rocks below the crust. These movements push and pull the plates, slowly dragging continents and oceans across the surface. Millions of years flash by. The planet moves. It reshapes itself again and again. After about 400 million years, all the islands and land masses merge into one single, gigantic supercontinent, Rodinia. In the warm, shallow waters around Rodinia, stromatolites continue their patient work, pumping oxygen into the atmosphere for more than 2 billion years. The planet is hot, around 35 degrees Fahrenheit, and the days now last around 18 hours. But even with oceans, land, and oxygen, Earth still looks nothing like the world we know. It looks more like Mars. It's 750 million years ago. Deep beneath the surface, an enormous force begins tearing the planet apart. The crust cracks, land stretches. It looks as if the entire world is splitting open. Only one force is powerful enough to do this: heat. Heat rising from Earth's molten core weakens the crust, pulling it apart inch by inch, year by year. The supercontinent that once dominated Earth began to break into pieces. This violent geological activity triggers massive volcanic eruptions. Volcanoes flood the air with carbon dioxide. That CO2 mixes with water vapor and forms acid rain. When the continent split, huge areas of rock become exposed for the first time. These rocks absorb the acid rain, along with the carbon dioxide inside it. Over time, enormous amounts of CO2 are pulled out to the atmosphere. Suddenly, there isn't enough carbon dioxide left to trap the sun's warmth. Earth loses its insulation, and then everything changes, fast. Within only few thousand years, temperatures plunged to around minus 60 degrees Celsius. 650 million years ago, the world has turned into a frozen wasteland. This marks the beginning of what scientists call Snowball Earth, the longest, coldest ice age Earth has ever endured. The more ice spreads, the more sunlight gets reflected away from Earth. And the more sunlight is reflected, the colder the planet becomes. The freeze feeds on itself. A planet that began as a molten ball is now locked inside a frozen tomb. Almost all sunlight bounced back into space. The warmth that once supported oceans and storms and clouds is simply gone. And at this moment, 650 million years ago, it seems like nothing, not even the sun, can save Earth now. For 15 million years, Earth has been locked inside a frozen shell. a world-sized snowball drifting through space. But nothing stays frozen forever. Something eventually has to set the planet free. The real question is, when it happens, will life still be there to witness it? Above the surface, everything is ice. But deep below, Earth's core is still blazing, hotter than the surface of the sun. Volcanoes have been erupting this entire time, relentlessly pushing lava upward. But their heat hasn't been enough to break through the miles of thick ice. Still, volcanoes doesn't only release that, they release carbon dioxide. Billions of tons of it. Before Snowball Earth, exposed rocks absorbed most of this CO2, but now those rocks are buried under ice, sealed away, so the carbon dioxide has nowhere to go. It builds up, slowly covering the planet like an invisible blanket. CO2 traps heat, and eventually that blanket becomes thick enough to hold the sun's warmth. Temperatures finally begin to rise. After 15 million years, the ice starts to weaken. Cracks form, meltwater gathers, the frozen shell begins to thin. Geologists believe that the weight of all that ice had pushed Earth's crust downward. Now, as the ice melts, the crust bounces back, creating new fractures, weak spots, and even more volcanic eruptions. Those new volcanoes release even more carbon dioxide, pushing temperatures higher and accelerating the melt. The planet is warming faster and faster. And something else is happening. Oxygen levels begin to rise. During Snowball Earth, sunlight still reached the ice. The sun's ultraviolet rays reached with water molecules frozen in the surface, creating hydrogen peroxide, an oxygen-rich chemical trapped inside the ice. Now, as the ice melts, that hydrogen peroxide breaks apart. It releases enormous amount of oxygen into the atmosphere. The Great Freeze is ending. And Earth, once frozen solid, is preparing for a dramatic comeback. Earth is waking up again, and it's a completely different world. It's now 600 million years ago. The atmosphere is warmer, like a comfortable summer day. A full day lasts about 22 hours, and the planet is covered in liquid water. Conditions are finally perfect for life. If you remember, before Snowball Earth, primitive bacteria lived in the oceans. But could anything have survived an ice age 75 times longer than the entire history of humanity? If life made it through the freeze, it would still be hiding in the oceans, the last place it was seen. Now, we jump to 540 million years ago. The oceans are rich with oxygen, and those ancient bacteria have evolved. A small number must have survived the longer winter beneath the ice, because suddenly Earth is full of new life. Plants cling to the seafloor, and nearby a strange creature moves along the bottom. Something that looks like an armored slug. It's called Vivaxia, one of the new complex, multi-celled organisms now appearing in the seas. Earth has entered one of its most explosion periods, the Cambrian explosion. With more oxygen in the oceans, life can grow bigger, harder, and more complex. Skeletons appear, shells emerge. The seas fill with worms, sponges, and trilobites, distant relatives of insects, lobsters, even scorpions. Life expands from microscopic bacteria to fully armed predators. Meet Anomalocaris, nearly 2 feet long, with huge eyes, sharp teeth, and grasping limbs. It has trilobites, with ease, especially those flipped upside down, exposing their soft bellies. And there is another tiny creature, Pikaia, just an inch and a half long, but incredibly important. It may be the first animal with a primitive spine. Over millions of years, this simple structure will evolve into the backbone found in every fish, every reptile, every mammal, and even us. What should have been a ruined ocean after Snowball Earth has instead become a thriving world of predators and prey, plants and animals, all taking on shapes we can finally recognize. Beneath the waves, tens of thousands of species now exist. Life is unstoppable. Now, let's jump forward to 460 million years ago. The continents are moving again, forming a new super landmass called Gondwana. The temperature sits around 90 degrees Fahrenheit and oxygen levels are nearly the same as today. You should expect forests, insects, animals, but the land is nearly empty. Only a few patches of algae cling to the ground. Why? Because of the sun. Its radiation is brutal and deadly. Anything that leaves the water is instantly exposed to lethal rays. Complex life is trapped in the oceans. But far above, about 30 miles up, something remarkable is happening. When oxygen meets the sun's radiation, it transforms into a new gas, ozone. Over the next 120 million years, this ozone gathers into a protective layer that wraps around the planet. It absorbs the sun's radiation, preventing it from ever reaching Earth's surface. Without the ozone layer, life on land would be impossible. But now, the shield is in place. Life begins to merge onto land. Small, mossy plants appear first, pumping out even more oxygen. And the moment they take hold, oxygen levels skyrocket. Earth is transforming again. The green planet has begun. About 375 million years ago, something new is swimming through Earth's water. It's a strange-looking fish called Tiktaalik, a creature that doesn't quite belong fully in the water anymore. It can lift its head using a flexible neck, and its spines act almost like legs. Slowly, carefully, it begins pushing itself onto land, and this moment changes everything. Over the next 15 million years, creatures like Tiktaalik evolve stronger limbs. They spend more time on land, where plant life is exploding. And by 360 million years ago, their descendants, called tetrapods, officially make land their home. From these early four-legged pioneers will eventually come dinosaurs, birds, mammals, and yes, us. The land they step onto is wild and lush. Mosses and giant ferns tower overhead, some reaching 100 feet tall. Until now, plants spread using spores, tiny, single-celled particles that depended entirely on water. But then, something revolutionary appears: the seed. This tiny package carries its own food and water supply. Unlike spores, seeds can travel far from water and survive for months, even years. Seeds spread life across the planet, and forests explode with growth. Every plant pumps more oxygen into the atmosphere, transforming Earth into something that finally starts to resemble the world we know today. Life in these new forests is unlike anything we see now. Fish thrive in the rivers. Plants dominate the land. And soaring above them is a dragonfly called Meganora, an insect the size of an eagle. What once were legs have evolved into massive wings, turning these predators into a master of the sky. Below, Other early land creatures roam. Millipedes crawl across the forest floor at 6 feet long, and scorpions stalk the shadows as large as wolves. These giants exist because oxygen levels are far higher than today, supercharging their breathing systems and fueling enormous bodies. But animals still face one limitation: they lay their eggs in water. That changes when a lizard-like creature called Hylonomius appears. It lays eggs on land, each one a tiny, self-contained world with all nutrients and developing baby needs. This is a game changer. The amniotic egg allows animals to leave water behind and conquer the continents. The first reptiles begin to spread. Hylonomius leads the way. But yet, even in thriving world, life and death walk together. Dead plants pile up over millions of years, forming thick, soggy layers. Buried under rock, compressed by heat and pressure, these layers eventually turn into coal. Every chunk of coal burned today comes from plants that died over 300 million years ago. But beneath the decay, life never stops. Seeds support, forests return, wastelands revive. For a moment, it seems like life has truly conquered Earth. But the question still remains, can it stay that way? 375 million years ago, the Earth is a world of giants. On the Siberian plains, herds of creatures graze, massive plant eaters that dwarf anything we know today. Evolution has taken a dramatic leap. Small lizards have grown into giant reptiles. These Coteros, distant relatives of turtles, roam the land. But for every herbivore, there is a predator. This is Gorgonopsid, a perfect engineered killing machine. Its saber teeth pierce the scuterer, blood following as the predator watches patiently. Yet before the hand can finish, something unexpected happens. The ground begins to shake. Beneath the surface, enormous pressure builds, and lava erupts, not from a single volcano, but across the entire landscape. This is a flood basalt eruption. Molten rocks push up through fissures in the crust, turning lush paradise into a fiery hell. The scuterers and gorgonopsids are among the first victims of what becomes the greatest mass extinction Earth has ever seen, the Permian extinction. Thousands of miles away, in Gondwana, it appears to be snowing, but it's not snow, it's ash carried by winds from the eruptions. The ash burns, suffocates, and blankets the planet. Sulfur dioxide in the air turns into acid rain, scorching the land. Life on land begins to collapse. Oceans are not spared also. Warming waters lose oxygen, and a pinky algae survives where nearly all else perishes. Methane, previously frozen beneath the seabed, escapes into the atmosphere, further rising temperatures. Earth reached nearly 105 degrees Fahrenheit, 11 degrees hotter than before the Siberian eruptions. By the time, the lava has poured out for 500,000 years, covering an area the size of the United States, with nearly 4 miles of molten rock. 95% of species are gone. Only a few creatures survive by hiding, scavenging, and burrowing underground. By 250 million years ago, Earth is almost lifeless. But change is coming again. 50 million years after the Permian extinction, Earth begins to heal. Temperatures stabilize, acid rains neutralize, and vegetation returns. One supercontinent remains, Pangaea, stretching from pole to pole. With 95% of life gone, the stage is set for a new ruler, the dinosaurs. The Ammosaurus appears, 15 feet tall, slow but dominated. Nearby, Dilophosaurus appears, small, fast and cunning. Hunts in packs, proving that size isn't always the advantage. Dinosaurs thrive, repopulating a planet still volatile and restless. The Earth itself remains in motion. The crust shifts, plates tear apart, and new oceans form. Around 190 million years ago, Pangaea splits, giving rise to the Tethys Ocean. Ocean currents bring nutrients, attracting fish in the millions, but also creating dead layers of dead organisms, or buried under the heat and pressure. Over millions of years, these layers become oil. Today, nearly everything made from petroleum, gasoline, plastic, paint originates from this ancient cycle of life and death. 65 million years ago, the ultimate change arrives from space. A colossal asteroid, 6 miles across, slumps into Earth at over 40,000 miles per hour. The impact vaporizes the asteroid, unleashing the energy of millions of nuclear bombs. Debris rains down across the planet. Tsunamis, earthquakes, and fires sweep the continents. The sky is filled with ash, blocking the sun for months. Vegetation dies, animals thrive, and the region of dinosaurs, 165 million years strong, comes to an abrupt end. But yet, in the shadows, mammals survive, small, adaptable, and often nocturnal. They thrive where larger creatures fail. With dinosaurs gone, a new era begins. 20 million years ago, Earth has all its continents and oceans, but one thing is still missing: humans. For them to evolve, the environment must change. After 4.5 billion years journey, Earth has finally shaped the world we know today. The story, from molten rock and meteors to oceans, mountains, and life, explains why everything around us exists. The skies above, the water we drink, the ground beneath our feet, and life itself. Our planet will endure for at least another 4.5 billion years. More wonders, more dangers, and more strange creatures lie ahead. The next chapter of Earth's story is still waiting to be written.